Hi everyone, this is Purnima Mahalingam. In this video lecture series, next we are going to discuss about a servo motor. Come, let's go to the top. So in this video series, first we can see the introduction about servo motor. What is servo motor? So it is defined as a linear or rotatory type of accelerator and provides fast precision position of control, closed loop controls. And compared to large industries electric motors, servo motors are not useful for continuous energy conservation. It is not used for continuous energy conservation. It has high speed response due to low inertia and designed with small diameter and long rotational length. Servo motor is a mechanism that is used to provide feedback to control speed and final position of the motor. This is a closed loop motor. Previously, we have seen the open loop motor. And internally, in a servo, a motor combines a motor feedback circuit, controls, and another electronic circuit. These are the components. Combined, it is known as servo motor. And construction-wise, we have a provider feedbacks and position sensors. And we have an feedback signal is compared with the input signal, and the error signals available at the output are detected and is not enough to drive the motor. And we have a servo amplifier, raise the voltage and power level of an error signals. And servo motors are divided into AC and DC servo motor based on the supply used for the applications. So brushless permanent magnet motors is also used for simple application due to their low cost, efficiency, and simplicity of the working. Here we can the servo motor, electrical motor. We have a electric motor, motor stay and gear, output shaft, and cross hambers, and etc. This we can see the overall view. And servo motor working principle. The servo motor works on the principle of pulse width modulation technique. And this is the angle of rotation. Here we can see the pulse width modulation is a control signal. We have a position sensor motor. We have a position sensor. We have an is given the speed is given the gearbox, and position sensor sense the position and gives to the comparator. And by using the control signal and pulse width signals, we are comparing and we are giving the error amplifier. And finally, the variable output is given, and that's given to the input to the motor. And finally, is given to the load. This is an closed loop control. This is then a closed loop control. Okay. Here consists of DC position sensors and DC small motors and a reference set is corresponding desires. And we have a control circuitry, etc. So potentiometer generator with are related with the applications of error amplifiers. And some pulse control methods used to create a DC reference voltage and applied voltage converters to the pulse width modulations. Here comes some of theory parts. We have a feedback signal corresponding to the present position of a load obtained by using position sensors. We have types of servo motors. We have DC servo motor, AC servo motor, position rotation, continuous rotation, and linear rotation. These are the types of servo motors we have. And these are the one of the DC servo motor. We used separate DC sources, and then this quite similar to the normal DC motors. AC servo motors includes the controller and its high design of tolerance and a high voltage and obtained more torque. So advantage of servo motors ability to produce high output power related to the motors and weight, and it can reach 90 degree at light loads. And the motor have a high torque of inertia and can accelerate load rapidly. It can provide quiet operations, run smoothly, and provide high accuracy. So the position of servo motor can be controlled using as compared to the other DC motors. Some of the disadvantages, the drawbacks. So the demands turning stability, the feedback loop, and some breaks the motor to be unreliable, and the overall system cost and initial cost are higher than that of the stepper motor due to the need of feedback components and etc. And it would the complex control to provide the encoder and electronic supports. Here coming final to the advanced applications, it's used in conveyor belts and is used in solar panel, cutting machines, and milling machines, and power steerings and braking systems. These are some of the applications. We have in supermarket, hospital, theaters. These are in this areas we are using for controlling. Where and all the controlling is needed, where the closed loop is needed, we are using the servo motor. Here comes small video about servo motor.
This industrial robot needs a drive with particularly high demands. Not only does the robot have to be able to accelerate and decelerate fast, also precisely positioning is required. In fact, here
So
is a three-phase
positioning
servo
is
motor installed.
important.
In this video, we will clarify the term servo motor and
Servo
servo
motor.
drive in general. Then, the three-phase servo drive. The servo motor is a part of a servo drive, whether brushless DC motor, synchronous, or a robust asynchronous motor. But one thing in common is the detection of the rotor position by a sensor.
So
It's either
resolver.
a solver or an encoder. In this case, you see an
You can
implemented
see that
encoder.
here we can see the
This sensor
input
device gives
sensing
feedback
device.
to a controller to keep,
This
for
gives
example,
the feedback to
function
the.
speed constant, or to
This is
raise
the
the target
sensor.
position as fast as possible. The servo motor system includes the servo motor with its feedback device, a servo
Feedback
amplifier,
device.
and a controller. But how do these devices work together?
Servo motion control systems. These are the servo motor control systems.
The servo controller sends low voltage control signals for position, speed, or torque to the servo amplifier.
The speed
Now these
amplifier
commands are amplified up to high
commands is
power,
amplified
which
to
the
high
motor
power and it
controls.
goes to this.
The electrical
This
pulses of the
happens.
sensor are sent back to the amplifier. This
The
amplifier
electrical pressure is
uses this
amplified.
information to control speed and rotor position.
Yes.
The job of the servo motor
So
controller,
feedback.
also named as the motion controller,
This is the
is to
feedback
close the
coil.
loop on the
You
system
can see this is
by
feedback.
constantly interchanging data with the servo amplifier.
You can
The
see it
motor
is in
parameters
constantly.
like torque, speed, or position can be
So the
adjusted
sensor
immediately.
it's giving back. You can see this a closed loop
Some
control.
manufacturers offer modules which combine the controller and the amplifier.
Combine the
So
control
you
and
have
amplifier.
fewer parts, fewer connections, and a smaller footprint.
Small. So combining of both. This is an AC servo motor.
Talking about an AC servo motor, you usually mean a three-phase synchronous motor
Three-phase
whose
synchronous
motor field
motor.
is excited by permanent
So
magnets.
bearings, rotors, motor starting, winding, motor power converters, controllers.
The stator winding
Stators.
produces a
We can see the stator windings here,
rotating speed,
speeds, etc.
and control.
These are the working animation of servo motor,
which can be achieved by an elongated shape. The functioning of a synchronous motor was already explained in another video of our Learn channel. Please check our playlist.
Okay, I hope you'll be understanding what is servo motor and how the motor controls, closed loop controls works, and how the DC servo motor and AC servo motor works. And with this video, we can end this video lecture series, and we can meet another video lecture series. Thank you so much.